Okay, it's time to start. Hello all and welcome to our 87th free webinar titled Process Safety Management in Oil and Gas Between Regulations and Implementation. Presented by our instructor engineer Ahmad Saleh. He is a professional EHS lead engineer in oil and gas field. He received a bachelor in geophysical engineering from Suez Canal University. He's working as field EHS gas manager in Apache Corporation, and he also worked in Khalda Petroleum Company, where he led a team of 40 people across control of work, firefighting, and environmental departments. He is also working as a member in Technical Secretariat of HSE Supreme Committee that was formed by His Excellency Egyptian Minister of Petroleum in purpose of establishing a robust roadmap to develop HSE management program within Egyptian oil and gas sector. He is a strong advocate for behavior-based safety and focus on EHS management system as a framework for regulating EHS for any organization, in addition to radiation protection program for operations and waste management. Before we start our session, I will make a small presentation about OPA upcoming courses plan. My name is Adel Tahir and I'm OPA Business Developer. Here is our 11th wave of live courses. We have conducted 2 courses, analytics and machine learning application within the oil industry, and sucker root pump courses in the past months. And we have 4 more upcoming courses: Impel Best Practices, Process Safety Management, which will be conducted by the same instructor of today's webinar, Engineer Ahmad Saleh, and Practical Reservoir Simulation, and Polymer Injection Modeling by CMG. Each course is a 1-week duration. You can scan this QR code to register in our upcoming courses. We have conducted more than 35 live courses, which are now available as recordings in reservoir engineering, rig and rigless operation, production technology, G&G, and miscellaneous pontoon. These prices are before discount, so you can scan this QR code to apply. And don't forget, we have a gift for you for all the attendees, a flash sale coupon that will be presented in the next slide. Don't forget to apply this coupon code before you purchase any course from our list. Here's our flash sale 30% discount. You can this code process 30 safety before checkout on our courses on our website to enjoy 30% discount on all our courses, whether they are live courses or recorded ones. This flash sale ends today, so make sure to enroll before 12. So here's one of our services called Mentorship, one mentoring session by highly experienced mentors, tailored based on the needs of the mentee. The request can include professional guiding for PhD and master in their thesis, helping undergrad students in their projects, practicing on how to produce output results from a software, explaining the know-how of a software or some of its parts. We have completed 45 mentorship program with more than 900 learning hours, and the mentees were from more than 8 different countries. You can scan this QR code to apply for our mentorship. Here's a glance of our OPA website, www.opacourses.com. So, how to be an OPA ambassador? There are two tracks to join our OPA Ambassadors community. Take one or more courses or just take a mentorship program. So you may be asking yourself now, what will I get from being an OPA Ambassador? You will get extra discount on all courses in the future and group discounts when you get your friends with you. Thank you for listening, and now it's time for our session. Engineer Ahmad, the mic is yours.
Thanks, Engineer Adil, for this introduction. I wanted to make sure that all of you already listening me well. The presentation is clear.
Yes, I can hear
Can
you
you
well.
confirm through message? Yeah, for all. Okay. Okay. It's my pleasure really to introduce such topic, and it's my pleasure to be with you through this free webinar. Again, thank you for Engineer Adil for your this introduction. Um, okay. Let's start, not wasting your time. Our topic today about process safety management between the regulation and the implementation. Let's firstly introduce the process safety concept. Let me firstly assure for you that all these webinar will be all the time will be an interactive. So don't hesitate to raise your hand. Don't hesitate to send me your question, your note, your impression about what I'm saying. Also, I will asking you sometimes to expose to your experiences and situations that you may face through your industry. Um, Process safety. If no one knows or really read or exposed to process safety before, um, process safety is a disciplined framework for managing the integrity of opening system and the process operating systems and the process. Flammable substances, like reactive substances, like maybe explosive substance. This is a hazardous substance. The goal of process safety and asset integrity is to prevent a couple of things. First one, the unplanned release. It's the goal of process safety to prevent the unplanned release. Second one, that which will result in a major incident. Unplanned release could lead to a major incident. So process safety is depend on preventing the unplanned release to prevent the major accident. Process safety not concentrated on the minor or the personal safety. Process safety is more collaborative and more subjective topic to uh, control such major incidents that affect the people offshore and for sure will affect also the assets of the company. What is the impact of process safety? Process safety, if it is not well implemented, unexpected release of toxic or reactive or flammable liquid and gases in processes involving highly hazardous chemical have been reported for many years. Many of incidents all over the world have been uh, already occurred due to such unplanned release. You can remember Flexporo, you can remember Deepwater Horizon in the Gulf of Mexico, you can remember many of major incidents, Bhopal in India. There is many major incidents all over the world happening till now, unfortunately. Monthly, there is a major incident happen in some spot on our world. So the another the incident, okay, we cannot by any means to prevent incidents 100%. But in various industries, especially in highly hazardous chemical, which may be toxic, reactive, flammable, and explosive industry, or maybe there is a combination between these properties. Some of complicated industries like petrochemical industry have a combination between these threats. The petrochemical industry especially have a chemicals which is reactive, and in the same way it's flammable, and in the same time it can be explosive, and if it is released it will be toxic. So it is a very complicated industry and have a combination of these hazardous chemicals, which for sure a process safety management shall be implemented in such industry. Historical disasters already happened all over the world in the past century and in the recent century. Many of these historical disasters have been took place and result in significant consequences. Significant consequences like multiple fatalities, multiple injuries, uh, destructive property damage. You can remember what happened in Flexporo, and can I just introduce to you this small video? I don't know why there is no voice.
Hello, Engineer Ahmed. Please make sure that you have screen sharing, that your screen sharing is on with the video,
Yeah,
not the
yeah,
presentation of slides.
yeah. I will transfer to the video.
Okay.
Yeah. This is what happened in Flexboro. Flexboro is in England. It's a small city in England. It was a chemical plant. There was a minor change happened in some piping, resulting in what you can see now. A major fire in a small tank transferred to the other tanks. Many of many of injuries. The town itself, the houses was damaged due to the impact of the explosion. The effect is not only on the plant and the stuff. The effect extended to the whole town. Uh, million of dollars was lost. The whole plant transferred to rubbish, as you can see. It's not rebuilt again after this major incident. Such incident was happened in one of the most important country all over the world. It's UK. The technology, the key in the level of safety. But as I said before, incident always occur. We cannot stop it, but we can decrease its impact. We can mitigate the consequences. We can prevent reoccurring, at least. Okay, let's get back again to the presentation. Okay, risk assessment. Why we transfer to suddenly to risk assessment? Uh, process safety was constructed on the hazards, prevent the major incident, prevent the unplanned release, which is a significant hazard, resulting in some risks. So, firstly, you have to know how to assess this risk, to start to control this hazard, and to start to implement your process safety program. The hazard resulting in some risks, so you have to imagine the risk scenario and list your existing controls, what you are do to prevent such risk. Start to evaluate your existing controls and make a risk rank for these risks. Then, if there is a residual risk after your existing control, if these existing control didn't satisfy you, this existing control cannot prevent the risk fully 100%. So you have to have an additional controls. Then you have to re-evaluate again your additional control and make a risk rank again to ensure that there is no residual risk or the risk already mitigated or completely prevented. This is the concept of risk assessment. By any means, by any tool, by any technique, the risk assessment is built and based on these simple, very simple scenario or process. So let's expose to the process hazard analysis. What is the PHA? I know that many of you have heard about the PHA, process safety analysis. Uh, process safety analysis is considered as the risk control arm. How to control the risk except through a technique to evaluate, to assess this risk, and to control this risk so you can control the hazard and make your process safe. What is the process safety? What is the process hazard analysis? Any employer all over the world must use one or more of the following methods or techniques as a prerequisite to determine and evaluate the hazards of the process being analyzed. What you can see now is the main types of the process safety analysis techniques. The most famous one is HAZOP. HAZOP is the most famous risk analysis technique. Also, what if, one of the most important risk analysis technique. FEMIA, LUPA, fault tree analysis, event tree, POTI, checklist based, and HAZARD, of course. What you can see now is the most important risk analysis techniques all over the world. We will expose in our webinar now to a small and brief introduction to the main risk analysis technique of this one. We will expose this through the course and through our webinar today to the four main types of risk analysis techniques: HAZOP, fault tree analysis, FEMIA, and LUPA. Firstly, HAZOP. One of the most important risk analysis depending on the intention. The intention is how your plant is expected to perform, how you expect the process will be carried out, how you expect your liquid or your gas will go through the piping, will go through your vessels, and how you will control it, how you can uh, produce your final product through this plant. So the intention for your plant is to expect how your plant will be performed. Also, HAZOP using a guide words. Guide words is one of the brilliant and what make the HAZOP is remarkable technique. It's used to qualify or quantify intention in order to discover the deviation. The main purpose of HAZOP study is to discover the deviation in your process. If you know how your plant is expected to perform, so you start to discover what is the deviation of the initial design by using such guide words. How you can use it? Some of these guide words like no, if no liquid, what happened to the pump? If no gas, what happened to compressor? Also the guide word less. If you have less temperature than the operating temperature, what can happen to your product? The guide word also more or part of as well as or reverse and other than, all these guide words is used to guide you. uh, that's why it is called a guide words. It's guide you to discover the deviation of your process. You ask yourself some questions using these guide words to know and to discover the deviation in your process. Study notes. That is the unit, the main unit of the hazard that you start to make your the P and ID of the plant from the designer and divide it into some nodes. What is a node? Node is a location on the plant and the instrumentation, the P and ID, drawings, setting a scope of study. If you have a plant, have a tank and a vessel and some pumps or a compressor and piping, you cannot study or make a hazard study for the whole plant at one time. You need to divide the plant into small units, which called nodes, which is a location on your plant. Taking this node, single node, and to start study the hazard study for the single node, to know and to discover the deviation of the process of this specific node. What is a deviation? I repeated the deviation word many times. Deviation is a departure from design intention. The designers, the engineering company, or the designer for your plant, for your process, already initiate a specific design. You need to know, is there any departures from the initial design or not? You need to discover if there any deviation from the intentions that the designer had been put for your plant. Causes. The causes is the reason deviations might occur. If you already discovered the deviation, you need to know what caused this deviation to start to put some controls to prevent this cause from reoccur again. Consequences. Ah, our target. Our target. Consequences is the result of deviation from the designer intention. You need to control these consequences. If you can control the cause, no consequences. But if the cause overcome your controls, what happened? Some consequences, unfortunately, will happen. So in the hazard study also, you have to have a mitigation tools to mitigate the consequences of the deviation that may be okay. Another marvelous tools, which is FEMIA, it stands for failure modes and effect analysis. FEMIA is used for many of uh, fields, not only in oil and gas fields. It may be used through the HR studies, by the way. And also, it may used for some instrumentation, which is the main target for FEMIA to be used for instrumental devices. FEMIA is a qualitative structure method for hazard identification. FEMIA is used to identify the failure in the process, the failure in your instrumentation, the failure in your device, the failure in your system, and to start know the effect of this failure by analyzing it. It's a powerful tool, can be used to improve the quality of your product or your processes. It's a preliminary failure analysis methodology, not a final one. It's a part of an measure analysis, widely used in many applications, as I already explained to you, like safety, reliability, processes, design, development of quality of product, and some systems like HR system, a way of the practical way. What can indicate the failure and what can FEMIA can detect? Firstly, the loss of operational function can easily be recognized and can vary from erratic performance to total breakdown. If you have a vessel working for producing some liquid or treating some gases, the designer put for you some operational function for this vessel. Certain temperature, certain pressure, certain liquid should be enter this vessel. Some instrumentation have to control the pressure, the level inside this vessel. So there is a setting for each type of this operational parameters. There is a setting for the temperature, not exceed a certain number. There is a setting for the pressure, not exceed or not drop down a certain number. So if you deviate away from this operational uh, parameters, you will have a loss in the operational function, which can be easily recognized by the instrumentation and can, starting from, make some disturbance in your process and can eventually lead to a total breakdown for your vessel and your process. The distortion. Any change in the physical shape of a part, it can be on a large scale. The distortion can be just a small change in the physical shape of a device, of the vessel, of a housing, of a pump. It's a small distortion. Any change in the physical shape, it will be an indicator for you that there is a failure here. You have to analyze it. The discoloration. Discoloration, it's a change in the color. It's a good indicator for improper process control. It's a good indicator for corrosion. Most of us can identify the corrosion by just a color. If the color of the pipe changed from a light color to a dark brown one, so there is a corrosion here. So discoloration, one of the good indicators to be identified just by your eyes. The smell, yes, smell, one of the indicators, or a percent of aroma or odors. Rubber or plastic component, by the way, or as example, يعني, rubber and plastic components and compounds have a very well-known smell. If you smell unusual smell, is often an indication of a damage caused by chemical, maybe chemical activity that come into your contact. So the smell also is a good indicator. A change in the material properties itself. If there is a loss or a variation in the initial characteristics of the material. If you have a material with a certain thickness, with a certain class, and after many years of operation on this material, which is constructing this vessel, you can detect that there is a thickness reduction, as example, in the material. So this is a change in the material properties. The initial designer put and set a certain thickness for this material. So if there is a change in the thickness, if there is a change in the material thickness, if there is a thickness reduction, that is means there is an erosion inside the vessel. There is a corrosion that eats the metal. So it's a good indicator to the failure. FEMIA using these indicators to start to analyze what happened to your process. The fault tree analysis, one of my lovely and beloved analysis techniques. Fault tree analysis provides a systematic approach to the identification of the combination between the possible occurs that could combine to produce an undesirable effect. You list all your possible occurs, any possible occurrences that can be combined and produce undesirable effect. You use the occurrences and the effects that it can produce to form the fault tree analysis. The possible combination of occurrences, once identified, are displayed graphically That's why fault tree analysis is a remarkable tool because it uses a graphic tree to show you what happened to your process. The frequency and the probability of these occurrences can be estimated to enable the quantitative analysis. One of the marvelous tool and the marvelous uh, step in fault tree analysis is that it is a quantified analysis. It can be used in a qualified analysis and can be used as a quantified analysis if you have the frequency and the probability of these occurrences. You can transfer it from qualitative to a quantitative analysis to of the undesirable effect to be conducted. How you carry out an fault tree analysis? It's important to select to define what is the top event, which is your base. You have to choose what is the top event that happened in your process. Maybe in your plant, the top event is a fire. Maybe in your plant, the top event is an explosion. Maybe the top event is someone fall from height. Whatever. What is the top event? A collision between two vehicles. So, what is your top event? You have to define it. Then, like I said, it's a machine or process failure, component failure, accident, explosion, system failure, whatever your top event. The fault tree is then constructed downward. You are putting the top event at the top of your graphics. Then downward of the top event, the fault tree start to be constructed. It will look like an inverted tree, branching downward rather than upward. Our last risk analysis techniques is the layer of protection analysis. LUPA. LUPA, one of a very comprehensive risk analysis techniques that depending on what already your existing layer of protection the designer have constructed for your process or your plant or your business. Then it starts to analyze each individual layer of protection. Are it is functionally working well? Is it need some modification? Is it need some verification? It can stand against the risk that it is built for, or there is another layer of protection shall be constructed to control your hazard. If you can imagine this graph in front of you now on the presentation, at the left, there is a risk of fire as example. You have to put a layer to prevent this risk. This is our first layer of protection, the prevention. If you cannot prevent the risk and already the fire happened, so you have to detect the fire before it escalates. So the detection is another layer of protection. If the detection failed, or if the detection already happened, but you haven't enough firefighting equipment to control the fire, so you have to have a compartmentation. You have to have a firewall. You have to have some compartment to separate the other healthy part of the fire to mitigate your losses. So the compartmentation is one of the layer of protection. Then suppression. Suppression or the firefighting agent, whatever the agent is used, if it is water, like in hotels, water is a suppression agent. Maybe the foam, maybe it's a gas like CO2 or nitrogen. It's a suppression system, or mixed agent or advanced agent like FM200. It's a suppression system. So the suppression system or the firefighting system is another important layer of protection. Evacuation. Evacuation, one of the layer of protection, yes. When you evacuate the building, once it's gone in fire, you save the people's life. So you mitigate the losses. It's right. Already maybe you will lose the whole building, the whole plant, the whole process, the whole production. But at least you save the lives. But without evacuation, you will lose also the lives in beside to the building or the process of the plant. So evacuation is one of the most important layer. The structural resistance, the material that the plant equipment is constructed by, the material and the structure of the building, the structure of the plant, the distance between the equipment. This is a layer of protection that saves the equipment from uh, affected by another equipment that already at risk. On the same way, Luba, as you can see at the left of the presentation, there is a prevention layers and there is a mitigation layers. From what we are already explained in the past presentation, in the past slide, there is some prevention layers of protection, like at the down, the blue one is the inherently safe plant design. Inherently safe, this is the structure and the design of the structure of the equipment or the plant design. The inherently safe plant design is one of the layer of protections that can prevent the release. If you prevent the release, there is no fire. The green layer is the high level process control. The high level process control, like the control instrumentation that can be installed, like the basic process control system, like DCS. DCS, one of the process control that you can monitor your whole important layer of protection. Another layer of protection, the yellow one. The yellow one, it's the alarm and operator intervention. If there is some release, some smoke, it's a minor leakage from the gas. It's a small spill of the chemical. So there is an alarm or an operator already on the ground that intervene and start to stop this leak, or at least report of it to trap down the equipment that is leak. In the middle layer of protection is the instrumented protection layer. It's the safety instrumented system, which is called in brief SIF. SIF. SIF is the safety instrumented system, which is the last layer of prevention layers. The last layer of prevention, which is the safety instrumented system, the instrumentation that is installed on your plant equipment to control what happened inside. Starting from now, you will transfer to the mitigation layers. The top red layers is the mitigation one. As you can see, the top red layers already the monster come out of the equipment. There is a release. So there is an incident. What you can do now is to mitigate, not to prevent. Already you have failed to prevent the monster to come out from the vessel. But it is not the end. You have to control and mitigate this monster from destroy your plant. How you can do that? By a mitigation actions, by a mitigation layers. Starting from the third layer of protection, the active protection layer. What is the active protection layer? Like relief valves, safety relief valves. When you have an overpressure inside your separator, there is a relief valve at a certain setting, start to open to transfer and to release all the overpressure out of the vessel. So you can prevent vessel explosion. Rupture disc. Rupture disc, one of the active protection layers. Fire and gas system, one of the active protection layers. Second one, red layer, is the passive protection layer. Passive protection layer, like embankment, which is a passive protection layer, like firewalls. It's a passive protection layers that if you have a liquid inside the tank, this tank have overflow occurred. So you have to have some bundles, some walls around, some dike around this tank. Why? Already the tank collapsed, already the liquid on the ground, that you have to stop this liquid from walk through your plant and destroy every equipment inside your plant, not like what we see in the Flexporo incident in UK. The top red layer and the last one is the top mitigation emergency for emergency response. Emergency response, the release already happened, the fire already happened, the explosion already happened. So there is plant emergency response have to be implemented. You have to some intervention from uh, external assistance, maybe if you have some assistance from a fire station like near your plant, maybe the armed forces in your country can help to mitigate and to control the emergency. Maybe you have to total shutdown for your plant to save the other equipment from the destruction. Okay, I excuse Engineer Adel to open some question about the topic or that already we discussed now. I need to hear from you, whatever you prefer through messages or if someone need to talk. I'm happy to hear from you. What is the most interesting tool from what I already explained to you, or what is the most interesting tool that you already use it or you are intended to learn about it? So the mic is yours
Thank you,
now.
Engineer Ahmed, for this great presentation. It was fruitful session for sure. But we will have 3 minutes break just to fill the feedback form that I will send in now in the chat box. Please, I want every one of you to fill this webinar feedback form, and let's get back to our Q&A part after 3 minutes. I will also enable you to unmute yourselves so you can open the mic freely if you want and ask your questions. Please note that we will continue our session after the Q&A. But we haven't finished yet. There is more about this topic. So if you have any question, please write it in the chat box or just unmute yourself and ask it before we continue our session. I think Engineer Ahmed, there is no one wants to ask any questions. So let's continue our session.
This is the last part of our webinar, PSM in the light of American, European, British, and Egyptian regulations. Why I chose this regulation specifically? The American people, as OSHA, uh, already construct a 14 element of process safety management. OSHA in America is have a point of view in process safety management through the 14 elements that you already show now in the presentation. What is the process safety information, the hot work permit, the emergency preparedness, the pre-startup safety review, management of a change, contractors, compliance audit, and so on. The whole 14 elements that is based on the process safety implementation in United States of America. When we transfer Center of Process Safety to another American institute, which have four main pillars to build the process safety management system. As you can see at the below graph, it's commit to process safety, understand hazards and risk, manage risk, and learn from experience. That's what is the main pillars for process safety from the Center of Chemical Process Safety, CCPS. The European people in the European Process Safety Center are mainly based on the CCPS, but the 18 elements that you already can see now, it's the fundamentals of process safety at the European people. What is the fundamentals? So you can imagine what the European people think about process safety. They think in double isolation, first line break, flexible hoses, and so on. This is what the European people think about the process safety, which is more similar and closely like what the international fundamentals of process safety. In the British people, in the UK, NABUSH process safety build on just four elements. The process safety leadership, they are focused on the leadership and what can contribute in process safety management system. The management of process risk, they are interested in the process risk, how to control risk, and what is the source of this risk from contractor, from shift handover, from risk management, from assets. What is the source of your risk? In element 3, the process safety hazard control. How to control element 2. Element 3, how to control element 2. Process safety hazard control to control the process risk. And the final one, the fire and explosion protection. This element 4, are talking mainly on the mitigation tools, how to protect the fire and explosion, how you mitigate the fire and explosion. That's how the British people think about process safety. What happened in Egypt? In Egypt, we have an Egyptian Process Safety Management Steering Committee, which called PSM Egypt. They have a well-known website, Process Safety Management, PSM Egypt. And this Process Safety Committee already have initiated 24 documents that controlling the process safety all over the Egyptian petroleum sector. So, what is the challenges and drive motives of process safety management implementation? As you can see, it related to the major incidents. It should be all over the regulations from American people to British to European, even in Egypt, there is certain regulations, certain guidelines, and certain procedures you have to walk, you have to construct. So actually, there is many challenges that will face you when you implement a process safety in your organization, in your plan. First, one of the most barriers, most important barriers, and most important challenges is the first one at the left, the cost. Sure, the cost and resources constraints. If you have a plant, have a certain firefighting equipment, so to transfer to another level of upgrading this firefighting system, you have to pay some cost. You have to provide some resources. So this is one of the most important challenges. Second one, the resistance to change and adaptation. If you have an old plant with an old brains working on inside this plant, if you wanted to transfer their minds from manual tools to an automated one, you have to change their minds firstly before you need to change the equipment itself. So you will face a resistance to change. Maybe starting from the management, passing through the senior or line managers, ending by the operators and the staff. All of these people will resist your change. But in the management of a change, there is a rule, a very simple rule and very effective one. If you manage to change the mind of 20% of these people, the other 80% change will not be stoppable. It can't be stoppable. No one can stop the change if you start or if you can manage to change a 20% of these minds. The third constraint and third challenge is the integration of new technology with existing infrastructure, with existing old technology. This is a very complicated uh, barrier, really. How you integrate the new one with the old one. Maybe you have some equipment 30 years ago already installed. When you call its vendor to change something, or you need a spare part to change a small part of this equipment, he called you, no, it's obsolete. I no more produce this part or this equipment at all. You have to purchase a brand new one. So this is a very challengeable resource you cannot afford. So maybe you have to some integration between the new technology, the new system. If you wanted to install the safety instrument system in your plant, and previously it was no safety instrument system. How can you connect the safety instrumented system, the new technology, with your old DCS system on your plant? Maybe it is very complicated. The fourth one, how you ensuring data quality, privacy, and security. This is a very challengeable barrier to ensure that your data is insecure. The fifth one, the continuously updating skills and knowledge. Every single day, there is a new knowledge, a new skill, and new information in our industry is already identified. So the concept of continuous improvement is very challengeable and a very famous barrier for all our industry. So there is a concept of best practice that already well known now for this barrier specifically. To transfer to implementation phase of process safety management, firstly, as a previous slide already showed to us, that we have some barriers. These barriers have to be identified. After identifying the barriers, you have to transfer to the implementation, to draw to yourself and your plant and your organization a roadmap. This roadmap will lead you to implement a robust process safety management system in your organization. As you can see at the top of this roadmap, there is a 5 phases. First phase, the light blue one, is the definition. You have to define the certain elements. You have to define your process safety leadership. Who is responsible to lead the process safety in your organization? Understanding the process safety hazard and risk. What is the process hazards and risk in my plant, in my organization? This is an important definition you have to identify. What is the risk management? What is my organization risk management procedures? You have to define your risk management, and also you have to review the improvement of this risk management. So there is a certain definition you have to identify. The second phase, the dark blue one, is the evaluation. You have to evaluate your requirements. You have to evaluate your risk. You have to evaluate your. You have to evaluate a certain terms and certain tools in your apply the leadership and the hazard control. How you can by theoretical mean, how you can apply it on them. The fourth phase, the yellow one, is the compliance culture. One of the most challengeable barrier in our industry is the culture. How you can change the culture of the people to be a compliance culture. How you can change the mind of the operator to change his intent from just working and obey your instruction to obey the compliance. I need to be compliant by the regulations. I need to comply with the procedure. I wanted to comply with the safe work instruction. I wanted to comply with the standard operating procedure. I wanted to comply what already defined previously. And final phase, the red one, is the compliance control. You have to have a safety leadership process KPIs, key performance indicators, that measures to you what are you from the best practice in process safety. Were you from the compliance to the local or international standards and laws? You need to understand the process hazard and risk KPIs, and you have to deliver this knowledge to your operators and your staff. And also, you have to have a KPIs for your risk management and risk management review. It's it's a journey. It's a roadmap. It cannot be an individual effort. It should be a combination between all departments inside the organization to apply such roadmap, starting from the management to the single operator inside a remote facility. All of these uh, long range of people inside your organization have to on this roadmap to be implemented. Thank you for listening. I'm sorry if I was talking too much. I wanted to hear from you. I will be interesting if I hear from you. Any question can be written, can be through your voice. I wanted to hear from you from now. And thanks again for Engineer Adder and for you for your listen.
Thank you, Engineer Ahmed, for this great presentation. If anyone has a question about the last part of the regulations, please ask it whether by typing it in the chat box or just unmute yourself and ask it.
Oh, good evening.
Hello.
Yeah, good evening. Courage is the name. I will want to ask one question as when you are upgrading your facility from a manual system to an automated driven system. Is it important to also include that information in the piping and instrumentation design plan? Will it be captured in the plan as per the changes you have made? That's what I want to know.
Sorry, the last part. If you wanted to put this upgrade to your P&ID.
Yes, yes. It's with this information be reflected in the P&I ID, that's a design plan of the plant.
For sure, any upgrade, any change that will happen in your plant should be through a management of a change procedures in your organization. The management of a change procedure, if you are following like Ocean as example, the management of a change, there is a certain document have to be upgraded after your change. And through the risk assessment that is done prior the change, you already list all your documents that have been intervened and shall to be upgraded to add your upgrade to it. If you have a manual system, you need to transfer it to an automated one. The automated system have to be also implemented on the document, not only on the ground. The management of change is the tool that controls such a change, even the change in the document only.
Okay, great. I think you have answered them. Uh, anyone has any questions? Okay, I think that's all for today. Thank you for attending, and thanks, Engineer Ahmed, for this great presentation. Don't forget to that you have the process safety management live course starting on July 27th. You have a promo code with 30% discount that will end today. So make sure you enroll in our next course before tomorrow. Thank you for listening, and I think we have a question in the chat. No, I think
Yeah.
okay. Thank you, Egbert. Someone is asking, what is the difference between mitigation and prevention?
Yeah, it's a great question. What is the difference between mitigation and prevention? Prevention is to make some barriers, some controls, prevent the hazard from occurring. If you have a liquid inside a vessel, when the liquid inside the vessel, it is safe. If the liquid get out the vessel, there is a risk. It can be fire risk, it can be toxic release, it can be explosion maybe. So just the liquid start to release from the vessel, there is a risk. But if the liquid is still inside the vessel, so the vessel body prevent the hazard or the risk from occurrence. So the vessel is a prevention tool. The vessel is a prevention control. But what is the mitigation? Mitigation, if the release already happened, unfortunately, I cannot prevent the liquid from get out the vessel, and the liquid already released to the ground, out of the vessel. So it can be ignited to transfer to a fire. It can be released as a toxic vapor will kill the nearest people. So you have to have some tools to mitigate the consequence of this release. If it is ignited and get fire, you have to have a firefighting system to put it down. You cannot prevent the liquid from get out the vessel, but you can control the fire from happen. Also, you can prevent sorry, you can also prevent the toxic release from happen. So any action that you are taking after the release happened, it's called a mitigation action. Already the incident happened, already the risk happened. So any other control after risk happened is called a mitigation. But each single control that you are taking before the release is called a prevention action. I hope that I already answered your question, Zidane.
So is there any more questions?
Someone asking for attendance link.
I've just
Thank
shared
you
with
too,
you
yeah.
the live course registration link. About the attendance, no worries. You will get your certificate automatically through our website. So no worries about the attendance or the certificate. It will be generated automatically. Thank you. Thank you all for attending. I think this is all for today. Thank you, Engineer Ahmed.
Thanks, Engineer.
I think we have a question. What is the difference
Okay, no problem.
between Hazoop and FEMA?
Yeah, it's FEMA, not IFEMA. The difference is the application. Hazoop is a risk analysis techniques used for identifying what is deviation of your plan. So it is a tool used some nodes, which is dividing your process into a small process and start to study what is the deviation in this small nodes. The deviation lead to consequence, which will lead to incident. So from the study, you can set some controls to prevent this deviation from happening. This is HAZOP, simply a comprehensive study for the plant. But FEMIA is also a risk analysis technique tool, but it for a certain device. It is for a certain process, for a certain equipment to study what is the failure happened already in this tool, in this equipment, in this process. So in FEMIA, the failure already happened, and you study what is the failure mode in this equipment, process, or whatever, and start to make an analysis to prevent the recurrence of this failure. But in Hazoop can be before you start construction of the plant. Hazoop is after design. Once the designer set for you the safe design, you start the Hazoop study to know if this design is safe to be constructed or not. I hope, Ekpen, that my answer is satisfying for you.
Yes, it's clear he answered. Okay.
Yes, thank you.
For the last time, I think this is over today. Thank you, Engineer Ahmed.
Thanks again.
And thank you all
Thank
for
you for
attending.
all. Thanks for all.